So this is the PDF file of the question. You know the case study question. It has 5 parts. You have to answer any 4 parts. The questions are given from some information which you have to read very carefully. So this is case study 1. A general election of Lok Sabha is a gigantic exercise. About 900 million of people were eligible to vote, and voter turnout to be 67% or highest ever. This is about your election 2019, and the pamphlet is given: My Vote, My Choice, One Nation, One Election, Festival of Democracy, General Election 2019. We will more focus on this writing part. What is given, we will read very thoroughly. First is I be set of all citizens of India who were eligible to exercise their voting right in general election held in 2019. So it is the set of citizens they have voted. A relation R is defined on I on the set of all citizens. It's like this. A relation is set of all order pairs V1, V2, voter 1, voter 2, where voter 1 and voter 2 belongs to set of citizens who were eligible to vote. Both use their voting right in general equation. This pair is, that means when V1, V2, both are casting vote, so both belongs to senior citizen. We are taking order pair of this relation. So this V1, V2 order pair belongs to the relation. Now coming to question. 2 neighbors, X and Y, they belongs to I. That means they are set of citizens who were eligible for vote. X exercised his voting right. A casted the vote, while Y did not cast in this general election 2019. Which of the following is true? X, Y belongs to relation. Y, X belongs to relation. X, X does not belong to relation. X, Y does not belong to relation. So certainly X is exercising the vote, means X is casting the vote, Y is not casting. That means this pair are not similar. So this pair does not belong to the relation. So which one will be correct? D will be correct option for this question. Coming to question number 2. Question number 2 is again about husband and wife, Mr. X and his wife W. Husband is X and wife is W. Both exercise their voting right in general election 19. Which of the following is true? There are again 4 parts. Both X and Y, W, husband and wife, and wife and husband belongs to R. Husband and wife belongs to R, but wife and husband does not belong to R. Both husband and wife and husband does not belong to R. Wife and husband belongs to R, but husband wife does not belong to R. So it is simple because both have exercised their voting right. So whenever husband and wife belongs to R, wife and husband also belongs to R. So which one is correct? A is correct option for this. Now coming to question number 3. 3 friends, F1, F2, F3, friend 1, friend 2, friend 3, exercise their voting right in general election 2019. Then which one is true? F1, F2 belongs to R. F2, F3 belongs to R. F1, F3 also belongs to R. Second is F1, F2 belongs to R. F2, F3 belongs to R. F1, F3 does not belong to R. Third option is F1, F2 belongs to R. F2, F2 belongs to R, but F3, F3 does not belong to R. And fourth option is F1, F2 does not belong to R, does not belong to R, does not belong to R. So when they are casting vote, the all pair are in the relation. So F1, F2, they are also part of relation. F2, F3, they are also part of relation. If we take the pair F1, F3, they are also part of relation because they have exercised their voting right. So A is answer of this question. Next is fourth part. The above defined relation is R. That means the relation defined on your question number 3. Question number 3 was F1, F2, F3. They all belongs to set I, that means senior citizens which are eligible for casting vote. Now if you will see for reflexive relation, options, let us see the options are axiomatic, transitive but not reflexive, universal relation, equivalence relation, reflexive but not symmetric, and transitive. Equivalence relation means it is both reflexive, symmetric as well as transitive. Now, what is reflexive? If F1, F2, this F1, F1 belongs to R, this relation is reflexive. That means F1, F2, F3 belongs to I. F1, F1 belongs to R. F2, F2 pair also belongs to R. F3, F3 also belongs to R. So here, when they are casting vote, so F1, F1 belongs to R. F2, F2 also belongs to R. F3, F3 also belongs to R. So it is reflexive. Then coming to symmetric. If F1, F2 belongs to R, if, then implies that F2, F1 also belongs to R. So this is symmetric also. Similarly, if F1, F2 belongs to R, F2, F3 also belongs to R. This implies that F1, F3 that also belongs to R. So this is transitive also. So this is an equivalence relation. The relation which is reflexive as well as symmetric as well as transitive is equivalence relation. So this relation is equivalent relation. Question of 5. If Shyam exercised the voting right in general election 2019, then Mr. Shyam is related to which of the following? Here sets are given. All those eligible voters who cast their votes, family members of Mr. Shyam, all citizens of India, and eligible voters of India. Mr. Shyam has exercised voting right. So he belongs to which set? He belongs to all those eligible voters who cast their votes. So A is correct option for this. So your answers are given, you can check. Now coming to question number 2. It's not question number 2, it is case study 2. Charlene and Danju are playing Ludo at home during COVID-19. While rolling the dice, Charlene's sister Raji observed that and noted the possible outcomes of the throw every time belongs to set 1, 2, 3, 4, 5, 6. Let A the set of players. So A is set of players means it is contains your Charlene and Danju. So A is S and D. B is set of all possible outcomes. So B is 1, 2, 3, 4, 5, 6. So A is set having SD and B is 1, 2, 3, 4, 5, 6. Now the question is, question started from here. Let relation is defined from set B to B. It is defined by all order pair x, y. X, y both are belongs to B, but y is divisible by x. That means when you will take B to B, that means you are taking 1, 1, 1, 2, so on up to 1, 6. Then you are taking order pairs 2, 1, 2, 2, up to 2, 6. Then 3, 1, up to 3, 6. Similarly, 4, 1, 4, 2, up to 4, 6. 5, 1, up to 5, 6. And last is 6, 1, up to 6, 6. So all this order pair is B cross B, or Cartesian product of B and B. Now from this we are taking only where y is divisible by x. Y is divisible by x. Y is divisible by the second set is divisible by first. So 2, 1 will be there. 1, 1 will be there. 2, 2 will be there. 3, 3 is there. When second element is divisible by first. So this will be satisfying the relation. So this relation will be reflexive once. Now coming to whether it will be symmetric or not. For symmetry, you know that if AB is there, BA must be there. So here for this relation, this satisfies the relation because 2 is divisible by 1. But if I write 2, 1, it does not belong to R because 1 is not divisible by 2. So this is not symmetric. So it is reflexive but not symmetric. So which option is there? Out of this, instead of going for transitive, you can set the option which one is correct. Reflexive and transitive or not symmetric. Here it is reflexive and symmetric. So which one I'll select? I'll select A. Let us see for transitive also. For coming to transitive, for transitive you know that if AB belongs to R, BC belongs to R, this implies that AC belongs to R, then only it will be a transitive function. So I'm taking the example, if 1, 2 satisfy this relation, 2, 4 satisfy this relation, does it show that 1, 4 satisfy the relation? That means here 2 is divisible by 1, 4 is divisible by 2, so 4 is divisible by 1. It is true. So this function is transitive. So it will be reflexive and transitive but not symmetric. A is correct. Coming to second one. Raji wants to know the number of functions from A to B. A has, let us see the option. How many number of functions are possible? 6 to the power 2, 2 to the power 6, 6 factorial, 2 to the power 12. You can also, if you know, you can find the answer yourself, or you should note this formula. If F has m number of element, set B has n number of element, the number of functions is equal to n to the power n, n to the power m. So it will be n has how many elements? B had 6 elements, so it will be 6 to the power 2. A has two number of elements. Set B has 6 number of elements, so it will be 6 to the power 2. So A is answer for this question. Then coming to part 3. Let R be a relation defined by R1, 2, 2, 2, 1, 3, 3, 4, 3, 1, 4, 3, 5, 5. The R is what type of function? Whether it will be symmetric, reflexive, transitive. It is not reflexive. It is not reflexive. Why? 3, 3 is not there. You can see 3, 3 is not there. 4, 4 is not there. So it is not reflexive. Then let us see whether it is symmetric or not. If 1, 2 is there, but 2, 1 is not there. 2, 1 is not there. So it is not symmetric. Then let us see for transitive. 1, 3 is there. 1, 3 belongs to relation. 3, 1 belongs to relation. Then if it would be transitive, then 1, 1 must be there, but 1, 1 is not there. So it is not transitive. So the answer will be none of these 3. Next, coming to fourth part. Raji wants to know the number of relation from A to B. We have finished number of functions. Now number of relation from A to B, how many are possible? 6 to the power 2 to the power 6 factorial and 2 to the power 12. A set A has m number of element. I am writing the formula, you can note down elements. B has n number of element. Then number of relation is 2 to the power m into n. So here m is your 2, n is 6. So it will be 2 to the power 6 into 2. That will be 2 to the power 12. So 2 to the power 12 is the answer. D is the answer of this question. Next, coming to fifth one. B, a relation different from B to B. And under R, this order pair are coming 1, 1, 1, 2, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. R is symmetric, R is reflexive and transitive, R is transitive and symmetric, and equivalence relation. Which one will be? 1, 1, 2, 1, 1 is there, 2, 2 is there, 3, 3 is there, 4, 4 is there, 5, 5, 6, 6 there. So it is reflexive. Then it is reflexive. So here it is reflexive. And for equivalent, all the 3. These 2 we may not check. Next is we have to see whether it is symmetric or not. 1, 2 belongs to R. 1, 2 belongs to R. But 2, 1 does not belong to R. It is not there. So it is not symmetric. Then coming to transitive. For transitive, 1, 2 is there. 1, 2 is there. 2, 2 is also there. So when 1, 2 is there, 2, 2 is there. So 1, 2 must be there. So 1, 2 is already there. So it will be, I am not going to see others one. 1, 2 is there. 2, 2 is there. 1, 2 is also there. When I'll say 1, 2, so here is 1, 2. So it is transitive. So this function is reflexive and transitive. Now